Okay, we're going to start off with a little review of surface area. We're going to look at finding the surface area of cylinders, cones, spheres, and rectangular prisms. There are 5 problems that we will go over together. Let's first look at finding the surface area of cylinders. Remember, the formula for finding the surface area of cylinders is S.A equals 2 times pi times the radius squared plus 2 times pi times the radius times the height. So in number 1, it says the radius of the base of a cylinder is 6 feet and its height is 9 feet. Find the surface area and round to nearest tenth. So using our formula, let's plug in what we know. Well, I'm just going to write on the side that our radius is 6 feet, our height is 9 feet, and surface area equals 2 times pi times the radius squared plus 2 times pi times radius times height. So plugging in radius for r, we'll have 2 times 3.14, so that's what we'll use for pi, times 6 squared plus 2 times 3.14 times 6 times 9. And at this point, you can just pick your calculator up, and as long as it says scientific calculator, you can plug the numbers in exactly how you see them on your paper. When we do, we get 565.2. And I don't have to worry about rounding to the nearest tenth because 2 is in the tenths place, and that's what my calculator gave me. Remember, our units for surface area are the same as area. So that's going to be feet squared. All right, for our next problem, we're going to look at a cone. And if you recall that the surface area formula for cones is SA equals pi times the radius squared plus pi times radius times the slant height. So L represents the slant height on a cone. And number 2 says to find the surface area of the cone, and again round to the nearest tenth if necessary. So you'll see our picture of our cone on the right, and I can actually mark on the figure. So 13 is L, that's our slant height. 5, which is in the circle, is our radius. Remember, radius goes from the center to the edge of a circle. We don't need that 12 inches in this problem, but I'm going to mark that would be our height. So the height is straight from the top of the cone to the radius, and you notice it forms a right angle, but like I said, we don't need to worry about that 12 inches for our formula. All right, so let's write out that surface area equals pi times the radius squared plus pi times the radius times the slant height. And we're going to plug in what we know. So surface area equals 3.14 times 5 squared plus 3.14 times 5 times 13. Okay, again, if you have a scientific calculator, you can plug that in just as you see it. And when we do that, we get 282.6. And again, our units are inches squared. All right, number 3, we're going to look at a sphere. So we have that the surface area of a sphere equals 4 times pi times the radius squared. And our problem says, how much plastic is needed to make a beach ball with radius of 20 centimeters? Okay, so we have our radius, which is 20. And that's the only unit of measurement that we need to plug into our formula. So let's write out that surface area equals 4 times pi times radius squared. Surface area equals 4 times 3.14 times 20 squared. And using my scientific calculator, I plug that in, and I get that surface area is equal to 5,024 centimeters squared. Okay, we haven't looked at a rectangular prism yet, but pretty much it's just the 3D of a rectangle. And if you recall, to find the area of a rectangle, you just take length times width. Well, now the rectangular prism has three measurements. It has a length, a width, and a height. So the formula to find the surface area of a rectangular prism is SA equals 2 times the length times the width, plus 2 times the length times the height, plus 2 times the height times the width, which, if you think about it, makes sense because there are 6 rectangles in our prism, right? We have one on the front, and then there's one on the back that matches that. Then we have one on the side, and there's one on the other side that matches. And there's one on the top, and there's one on the bottom that matches. So that's how we get 6 different rectangles, and why that we're multiplying each set by 2. So I can mark on my figure, so 14 meters is our length, and 6 meters is the width, and 10 meters is the height. We can just substitute those numbers into our formula to calculate the surface area. So I'm going to write out the formula. Surface area equals 2 times length times width, plus 2 times length times height, plus 2 times height times width. Okay, so we said our length is 14, so we have 2 times 14, and then our width is 6, so times 6, plus 2 times 14 times 10, plus 2 times 10 times 6. Okay. You can plug all of this into your calculator at once. I chose to simplify each area or each kind of set there. And I got 168 plus 280 plus 120. So that's the area of each set of rectangles. And then if you add them up, you get surface area equals 568 meters squared. Okay, here's our last problem in this section. It's a cube. So a cube is a type of rectangular prism, but more specifically, a cube is a 3D square, so therefore all of the sides are the same, your length, your width, and your height. So you could use the formula for surface area of a rectangular prism, or if you notice, our cube, like a rectangular prism, has 6 sides, and all the measurements are the same, so we can use this formula that surface area equals 6 times s squared. So s represents the sides, and the reason it's squared, if you remember, to find the area of a square, we take s squared, and if there's 6 sides, we just multiply by 6 here. So if we want to find the surface area of the cube, I'm going to use that formula SA equals 6 times the side squared. Well, each side is 5, so SA equals 6 times 5 squared. Now you can simplify that and take, 5 squared is 25 times 6, or you could just plug it right in your calculator as is, and you get 150 millimeters squared. Okay, so that finishes our review of surface area, including the rectangular prism and the cube, which we hadn't looked at yet. So if you need to, go ahead and review this video again, and go ahead and give those practice problems a chance on the worksheet. I want you to go ahead and try those practice problems that I also posted. All right.